So we have here two pieces of tubing from the that resulted from the samples I made using the helically wound woven carbon fiber tubing. This sample here has 2 layers of the fabric, and this sample here has 3 layers of the fabric. And I've weighed them, measured them out, and the one with 3 layers weighs approximately 1.19 ounces per foot, and the one with 2 layers weighs about 0.84 ounces per foot. So we can say that approximately the tubing is going to weigh 0.4 of an ounce per foot per layer of cloth. Now these were samples investigating how thick it has to be a torque tube, and we want to prevent local buckling or collapse of the tube so that there's sufficient torsional strength. The driving factor is the buckling, once again, like most of this design. So, to prevent buckling, we need enough layers such that the tube is much stronger than it needs to be for the torsional strength. That by the time we get it so that the strength this way is high enough to keep it from collapsing, it is then way too strong for torsional strength. So we have an interesting problem there. You see the one with 2 layers, if I press really hard, I can oval it out a little bit, and that's not necessarily a good sign. The one with 3 layers, extremely stiff, cannot oval it out hardly at all. If I used this tubing for torque tube, it would weigh about 9 ounces per side of the aircraft. Now that doesn't sound like much, but that's more than 1/2 pound per side. So just for the torque tube alone, we have 1 pound in the aircraft weight. 1% of the total aircraft weight just in 2 torque tubes. So that's unacceptable. And that's without fittings and so forth, reinforcements and what have you. Simply too heavy. The one with 2 layers, better. We're talking something about 3/4 of a pound for the 2 torque tubes alone. I think that's still too heavy, and I believe there's a way around it. When I made the samples that are 1 layer thick in the middle, you can see they're quite squishy, and that's a bit of a problem. They would very good torsional strength, but eventually that's going to collapse under load, and it could fail fairly easy. So the idea here is to stiffen it such that it doesn't collapse, yet without adding a bunch of layers that would add weight. So that's the challenge. I think the answer is going to lie in creating a tube that is 1 layer thick and then putting hoops of carbon fiber around it, which will essentially be 1 or 2 layers of carbon fiber cloth, say 1/2 inch wide, dispersed maybe 1 foot apart, maybe only 6 inches apart. So by putting these hoops around here like this, it will stiffen the tube locally and prevent collapse. In other words, we'll be reducing what is called the critical buckling length from the entire length of the tube to smaller segments, and that essentially makes a tube that is much stiffer, yet we're only adding cloth as needed and thereby maintaining minimum weight. So an 8-foot long tube that's 0.4 of an ounce per foot is going to weigh less than 1/4 pound, and by the time we add the hoops to it, we're probably somewhere in the order of 1/3 of a pound, or for the 2 torque tubes, 0.6 of a pound, which is more acceptable. And making a tube out of 1 layer of cloth and little hoops, very easy. I get some woven carbon fiber cloth and just wrap it around every so often. It's a matter of sitting down and making the calculation of how closely spaced those hoops have to be. And I think that's where we'll end up. We have some other experiments to do on torque testing, and one of these 2 tubes that are 1 layer thick in the middle, thicker on the ends, 3 layers thick on the ends to accept the fittings, one of these I'm going to leave as is, and the other one I'm going to fill with expanding urethane foam, and that will prevent collapse. I don't know what the end weight will be, and that's part of the experiment. We'll find out. Before we go on and make more tubing, I'm going to shoot some video of installing fittings in these three tubes that I'm going to use for torsional testing. The little fittings are just, they're wood, blind nut. I'm going to have a bolt through them into the blind nut, and these will get epoxied into the end of the tube like this, such that I can put a torque wrench on this nut, mount this in a fixture, and apply torque to them until they fail, and then I'll find out how strong they are. This tube, the sandwich panel tube that I made, I'm actually going to experiment with the gear fitting that I'm thinking of using for the control system. You'll see that this is a toothed aluminum gear, and this is designed to go with a Kevlar / urethane belt that is used for 3D printers and other printers. It has zero stretch on those belts, and they are extremely strong yet lightweight, and this will go in the end of the tube and be part of the drive system for that tube. You'll see as we go along how that system is going to work.